that Christians are creationists because we have to be, because we have this blind faith in the book, in the Bible. And then if we could take off these blinders of faith, then we would see all the objective evidence for the millions of years and neo-Darwinian processes and so on. And I'm one of many for whom the opposite is true. I'm getting some crackling and feedback up here. I don't know if that's visible or audible to anybody else. Not bad. Not bad? Okay. I'm one of many for whom the opposite is true. I became convinced by the evidence first that creation was true. And then that opened the door to becoming a Christian later. Now, believing in creation is not sufficient to make one a Christian. Obviously, that's the work of the Holy Spirit, right? I mean, there are Muslims who are creationists. But nevertheless, there are many for whom evolution is their stumbling block, as it was for me. And that's why I'm so passionate about the subject now, is to share this information with people. And our topic tonight is focusing on, as you see, the James Webb Space Telescope, the Big Bang and creation. How do the new discoveries from this new telescope affect our understanding of origins, especially in the area of astronomy? Now, the Bible tells us, my clicker would work. What's that?
You got the expert on.
Well, my clicker's not working. The Bible tells us that the heavens declare the glory of God. And it does this in so many ways. These heavens, plural or singular, not sure. But the heavens do this in so many ways. And in fact, our ability to perceive God's glory through the contents of the cosmos is better now than it has ever been before in human history. I mean, humans have always been able to gaze up into the sky and wonder. But today we have not only instruments like telescopes, even our ground observatories have capabilities that they've never had before. We can now use lasers and adaptive optics to compensate for turbulence in the Earth's atmosphere so that even earthbound observatories can get better views of the heavens than they ever could before. But in addition to that, of course, we now have space telescopes. The Hubble Space Telescope was the first one of that variety, getting above Earth's atmosphere and above its the distortion that it introduces into observation. And the latest iteration of this is the James Webb Space Telescope, a very expensive project, rather overdue by the time it finally went up on December 25th in 2021, but successful in some ways beyond, almost beyond hope, because this was a very difficult project to pull off. A long series of steps had to go exactly right in order for this to work. And in many of those steps, there was only one chance at it. But everything indeed succeeded, and now we are getting better pictures than we ever have before. For example, on the left here, we have a photograph from the Spitzer, which is already a very good instrument. Here's the same photograph taken from the Webb. So you can see how much additional detail and clarity we are getting with this new instrument. But this is more than just a matter of better pictures. Webb was designed specifically to look further out into space than any other telescope before. And that provides certain capabilities. As this NASA page said, Webb is a powerful time machine with infrared vision, meaning it's designed to look more into the infrared than other telescopes are, that is peering back over 13.5 billion years to see the first stars and galaxies forming out of the darkness of the early universe. From a secular perspective, from astronomers who don't believe in the creation account, they want to believe in the Big Bang billions of years ago, the farther out we look into space, the farther back we are looking in time. Because the idea goes that as we are here and looking farther and farther out, we're seeing things where the light took longer and longer to reach us. Therefore, we are seeing those objects as they used to be farther back into time. And James Webb can look so far out that, in theory, had the Big Bang occurred, we should be able to see not quite to that point in time, but almost that far back. Now, there's issues surrounding this idea of looking farther out means you're looking back into time. We're not going to talk about that tonight, though. For tonight's purposes, we'll accept their way of looking at things and matching distance to time and seeing if what the observations are showing us actually matches secular expectations. So here's an outline of our time here this evening. We're going to start by asking the question, according to the Bible, what would we expect the James Webb Space Telescope to show us? Conversely, according to the Big Bang model, what should James Webb reveal? Then we're going to talk for a bit about the Big Bang model itself. We'll see that it's not a good model to begin with. And then we'll see that the new discoveries from James Webb are actually making the problems for the Big Bang model even worse than they were before. So we will start with the first of those. According to the Bible, what would we expect as we get better and better views of the heavens? Well, the Bible says in the beginning, God created the heavens and the earth. Familiar verse to us, I would hope. It says, God said, let there be lights in the firmament of the heaven to divide the day from night. Let them be for signs, seasons, day, and years. So the Bible says the Lord created the contents of the heavens, and he did so for very specific reasons. And we would therefore expect the cosmos to be functional when the creation was finished. We would not expect to see immature objects in the deep cosmos as they were developing over time, because we would expect the Lord to make things functional when he made them. So that's our expectation from the Bible. From a secular perspective, though, the opposite is true. Secular astronomers believe that the universe formed in a Big Bang event some 13.8 billion years ago, that this Big Bang made energy condensed into matter gathered together into stars gathered together into galaxies, and eventually planets formed around some of those stars, and on at least one of those planets, people eventually evolved. Now, lots of problems at various points in that model. One of our key points for this evening is the formation of galaxies. This model says that you would need 3 to 6 billion years for galaxies to form. So a billion is 1,000 million. So, and a million is 1,000 thousands. So if you count to 1,000 times, you've reached 1 million, and do that another 1,000 times, that's a billion. So if the universe is supposedly 13.8 billion years old, supposedly the first 3 to 6 billion years of that time was necessary before galaxies could begin forming. And James Webb can indeed look far back enough into the universe, or I should say deep enough into the cosmos, that from a Big Bang perspective, we should be seeing almost back to the beginning of time itself. Not quite that far, but still very close. Certainly close enough that, as this quote says, we should be able to see the first stars and galaxies forming out of the darkness of the early universe, if this model were correct. So having established some expectations, let's move on and talk about the Big Bang model itself. Is the Big Bang actually a good cosmological model? Well, no, it has a number of problems, and I have an entire talk just on this. We're not going to do all of that tonight, but we will visit a few. One of the major problems of the Big Bang model out of the gate is that it is a secular cosmogony. So secular meaning it's a model that does not include God. Cosmogony means history of the cosmos. So Big Bang is an attempt to explain how the universe got here without God. As such, it is a secular cosmogony. However, all secular cosmogonies, not just the Big Bang model, but all of them, have a problem that I like to call the secular dilemma. And it's based on this simple question. So just 6 words. Did the universe have a beginning? If you are a secular modeler trying to account for the universe, then you have to answer this question very early on in your thinking. Because whether the universe did have a beginning or did not have a beginning in your model, you're going to wind up with very different models, right? So you have to figure this out before you can proceed much further. Now, how many possible answers are there to this question? Did the universe have a beginning? Just 2, right? Not a trick question. Either yes. My clicker's still not working. Okay. Either yes, the universe had a beginning, or no, it did not have a beginning. And if it did not have a beginning, then it's always been here, which means it would be eternal. Now, what do I mean when I call this a secular dilemma? Well, a dilemma is a choice between equally unfavorable alternatives, meaning that you have to make a choice, but you don't want to make a choice because all of the options are bad. And this is a dilemma for secular modelers, this question, because of the 2 possible answers, yes and no, each one violates a different law of physics. So you have to pick which law of physics you want to violate in your model if you are a secular modeler. So let's talk about why that's true. Let's talk about the first option. Yes. Yes, there was a beginning. Well, if there was a beginning to the universe, and if the universe is everything, which is what the word means, then everything had a beginning. So if everything had a beginning, what was there before that beginning? There had to be nothing, right? Because if there was something before the beginning, then whatever it was that began wasn't everything, right? It was only part of everything. So it wasn't the universe. So if the universe, which is everything, had a beginning, then before the beginning, there could only have been nothing. So I have a picture here of what the universe looked like before the Big Bang. That's nothing. Right? Of course, it's just an artist's conception, so I took some liberties. But if this was truly the case, then nothing had to make everything because there was nothing else around to make it. But can nothing make everything? Can nothing make anything? No, of course not, because nothing can create nothing. Nothing can do nothing. From nothing comes nothing. As Dr. R.C. Sproul once said, if there was ever once truly nothing, there could never be anything. And as Dr. Phil Fernandez once said, you can't tell me nothing made everything. I know too much about nothing. So now, so far, that's more of a philosophical argument, right? But turns out there's actually a principle in physics that makes this very concrete. It's called it used to be called the first law of thermodynamics. Now it's more broadly known as the conservation of mass energy, or the conservation of matter and energy. So this law tells us that the total amount of matter and energy in the universe is conserved. It never changes. So you can change the relative amounts of each, but the total combined amount can never change. What do I mean when I say change the relative amounts of each? Well, physics now understands that matter and energy have an equivalence. There's a relation between the two. You may be familiar with the famous equation E equals mc squared. So E is energy, M is mass, the amount of matter or physical stuff you have, and C is the speed of light, which is a very large number. So if you remember your algebra, that tells us that a little bit of stuff contains a lot of energy, and you can convert back and forth between the two forms. So the most efficient way we know how to convert matter to energy is in a nuclear explosion. A little bit of stuff turns into a lot of energy, right? We can go the other direction too and turn a lot of energy into a little bit of stuff. We do that in particle accelerators. So you get little chunks of matter, little chunks of stuff zipping around close to the speed of light, smash them together. More stuff comes out of the collisions than went in. Not just the number of particles coming out, but the actual amount of matter, of physical stuff. But are we creating matter from nothing? No, we're converting the kinetic energy, the energy of motion, into matter. So we can convert matter to energy, or convert energy to matter, but we can't create either one from nothing because that violates this very fundamental law of physics. And we even see this law of physics in our lives every day. I mean, think about this. Why do you need to eat food every day? Regardless of how difficult the process might sometimes be. Because your body needs energy to operate, can't get it from nothing because that violates physics. So you have to get it from the chemical energy stored in the food after you successfully get it in your mouth. But that's a problem outside of physics. So why do you get a bill from the power company every month? Because your appliances need energy to operate, can't get it from nothing, that violates physics. So it has to get it from an external source, the power company, which also can't get it from nothing because that violates physics. It has to produce it by getting chemical energy out of coal, or gravitational potential energy out of flowing water, or solar energy from the sun, which also can't make it from nothing because that violates physics. The sun has to burn its own version of fuel in order to do that, and so on and so on. So I'm belaboring the point, but you can't get matter or energy from nothing. That's what this law of physics says. In fact, we couldn't even be seeing this presentation tonight if it weren't for this law, because some of the principles of circuit design are based on this law of physics. And this is a very fundamental law. It permeates all of physics. As one of my textbooks says, conservation laws are the guiding principles of physics. These are absolute conservation laws. They are always obeyed. So this tells us something could not have come from nothing. Now, if you're interested in origins and science in general, you're probably aware that some atheists claim something can and did come from nothing. In fact, there's been books written to that. I'm not going to deal with this now. I will just say that these claims are wrong. If we have Q&A after, which I'm hoping we will have time for, and you're curious about details, you can ask me then. But for now, we'll just move on and say, fundamental physics says something cannot come from nothing, which means the universe could not have had a beginning. So that option, that answer to this question is off the table, according to physics. What about the other available option? The answer of no, there was not a beginning, which means the universe must be eternal. Well, here we can look at a second law of physics called the second law of thermodynamics. We talked about the first, and now this is the second. And I like to illustrate this one with coffee. So you walk into a room and there's a hot cup of coffee sitting on the table. How long has that cup been there? A long time or a short time? Short time. Why? Because it's still hot. It hasn't cooled off yet. Can it have been there forever? No, because had it been there forever, it would have cooled off forever ago, right? So this process of hot things cooling off tells us we can use coffee as a crude form of clock. We can apply that same logic to the universe and figure out that the universe can't be eternal for the same reason. Is there any hot things in the universe that haven't cooled off yet, but are still doing so? The sun and stars, right? Oh, excuse yourself. It's your phone on airplane? We're taking a picture. See? Yeah. Nice try. Was it Oh, okay. Are we getting less feedback now? No, they're still crackling. Yeah. I thought I heard wheezing too. So, same logic applied to stars. Stars will cool off over time. They have limited amount of fuel, and every one is either going to burn out or some of them will explode. But in any case, every star eventually will go away. But nevertheless, they are still there. That tells us the universe has been there forever. Is there a handheld I can try?
Yes, sir.
Yeah, let's do that. I can't find the button on this thing, so yeah, you can turn me off up there maybe. Now we get finger noises, even better. Thank you for your patience. I know bad audio is not fun. Do we need to test levels or are we good? Okay. Should I keep going meanwhile? Yep, okay. So the fact that stars are still there, that they haven't burned out yet, tells us that the universe hasn't been there forever, which means it's not eternally old, right? Now, some people say, wait a minute, new stars can form. There's problems with this idea, as we will see here shortly in this presentation. But for now, I'll just point out, even if that were possible, star formation still requires energy, of which there's a finite amount in the universe. So if the universe were eternally old, all the energy for star formation would have been consumed forever ago as well. So if the universe had been here forever, we would see all the heat in the universe spread out evenly, because that's what heat does. It distributes itself. But that's not what we see. We see vast expanses of cold space punctuated by very hot stars. So that tells us the universe is not eternally old, just from this simple fact. Now, you will sometimes hear Christians say that we should embrace the Big Bang model because it shows that the universe had a beginning and is consistent with Genesis, and we need that to prove there was a beginning to everything. Well, that's not true on multiple levels. Number one, the Big Bang is actually inconsistent with the book of Genesis. But my point for right now is we don't need the Big Bang model to show that the universe had a beginning. If you want to prove the universe had a beginning, walk outside and look up. Do you see the sun during the day? Do you see stars at night? If so, the universe hasn't been here forever, which means it had a beginning. And the sun is a daily reminder of that. So back to our dilemma, we already saw that the yes option is denied by the first law of physics, something can't come from nothing. But now we see that the second option is also denied by physics because the universe can't have been there forever. It can't be eternally old. And what other option does the secular modeler have? None, because those were the only two options he has available to him. And both of them deny physics. Or I should say both of them are denied by physics. So a secular modeler who's creating a secular model of origins for everything doesn't get the privilege of making a model that's consistent with all of physics. His only option is to choose which law of physics he's going to violate in his model. As Christians, though, we have a third option. Yes, the universe had a beginning. We know that because there's still the sun and stars, etc. But the beginning didn't violate the laws of physics because a supernatural creator who is outside of physics is responsible for it all. Because if you think about it, there's really only three possibilities to explain why the universe is here. Either it was formed by a creator, or it formed without a creator, or it never formed at all because it has always existed. There's always been something. So do we agree those are the only three logical options to explain how the universe got here, right? Well, we already saw that option two, it forming without a creator, means something had to come from nothing. The universe had to create itself. which physics does not allow. And then we saw that it can't have been here forever for the reasons we saw. So the only logical option left is that it was indeed formed by a creator. And sometimes Christians feel defensive about believing in creation openly, especially in a debate with someone, because you feel uncomfortable that you're endorsing a miracle, that you have to resort to a miracle. Well, no, the point of what we just saw is everyone has to believe in a miracle. If you make a model that violates the laws of physics, that's a miracle, right? So the difference is we believe in a miracle while knowing who the miracle maker is. The secular modeler has to believe in a miracle while denying that miracles are possible. So you see who's being inconsistent there. So that's what I call the secular dilemma, and not merely a philosophical question, by the way. This is a great conversation starter. If you're talking to someone and want to get them thinking about some of this, ask them, hey, what do you think? Did the universe have a beginning? And then as they think of an answer, you can explore the implications of that. This won't work with everybody, but it will work with some people. It worked with me. This is the question that ultimately is responsible for me being here, trying to solve this problem. I would also argue too, now the Bible doesn't say this is just my opinion, but I would view this dilemma as evidence of God's grace. Because the Lord could have created the universe any way he wanted, right? He could have made a universe that looks like the outcome of natural processes operating over millions of years. But he didn't do that. Perhaps of course he would know. Had he done that, how many of us would struggle believing in his creative handiwork despite what our senses appeared to be telling us? I mean, I think I would fall in that category. So in his grace, he didn't do that. He placed us in a universe that looks created. The laws according to which the universe operates also show us that the universe couldn't have got here on its own. And I think that's wonderful. So that's the first problem with the Big Bang model. It's a secular cosmogony. Any secular attempt to explain the universe is going to violate physics one way or the other. And by the way, this isn't limited to the Big Bang model. Any secular cosmogony is going to have that issue. What about some other parts of the model? What about star formation? I mentioned earlier that I was going to revisit this, so let's do that now. How do stars form? Well, we are told that stars will form on their own from collapsing gas clouds. Now, we certainly see lots of gas clouds in space, for sure. Why would a gas cloud collapse? Well, we are told that all the molecules of gas in the cloud are going to be pulling on each other gravitationally, which is true. And so they will therefore all gravitate toward the center of mass, which is also true. In so doing, they will compress the gas. And if you compress a gas far enough, it'll heat up and eventually fusion will ignite. And then you have a star. So you'll be told this is where stars come from. The problem is there's more at work in these clouds than merely merely gravity. There's also gas pressure. So gravity is pulling all the molecules together. Gas pressure is forcing the molecules apart, opposite to what star formation needs. And imagine, so we have these gas clouds in space. So by definition, a gas means all the molecules are unconnected from each other. They're all moving around, bouncing off each other. So in the middle of a cloud, a molecule will move a bit, hit another molecule, ricochet off of it, move a bit, ricochet off another one. So the molecules here are all banging off of each other, moving around. That's all fine. But here we have space, and here we have the edge of the gas cloud. So think of the layer of molecules on the very edge of the cloud. Now, they're all moving in random directions. So that means on average, half of them are moving some inward direction, whether straight in or side or off angled, whatever. Those are just going to hit another one and move around as we just discussed. But half of them are going to be moving some variation of outwards, whether straight out or at an angle or whatever. They're not going to hit anything because they're on the edge. They're going to move off into space and leave and not come back. Well, when the outer layer of gas molecules leaves, that uncovers the next innermost layer. That becomes the outermost layer. It does the same thing. It dissolves, dissipates, better word. It dissipates too, which uncovers the next layer and so on and so on. You keep peeling the onion until there's no onion left to peel, right? So gas clouds will, although gravity is trying to pull them together, gravity is very weak compared to the gas pressure. Gas pressure gets worse, by the way, it gets higher as the cloud gets smaller. So even if gravity does shrink the cloud a bit, that increases the pressure, which pushes it back out. And meanwhile, you have molecules leaking into space from the outer edges. And this process keeps going until there's no cloud left to dissipate. Now, you might be wondering, wait a minute, if a star is a big ball of gas, which I implied earlier, which is true. Now I'm saying gravity and gas pressure isn't going to work. How then can stars exist? Once the cloud is small enough to be a star, gravity is strong enough to hold it together against gas pressure because gravity is stronger over small distances. So once you have a star can last. But while it's still a gas cloud, gravity is relatively weak compared to gas pressure. And so getting it there is the problem. Okay, that was a long explanation. So this being the case, and this not being very complicated physics, secular scientists know this as well too. How then do secular scientists propose to overcome these problems to say that stars could form on their own? Well, they have several possible solutions. And the three biggest ones are compression, cooling, and collisions. This is how stars form according to secular modelers. So let's talk about that briefly. So compression occurs as a result of supernova explosions. So supernovas are violent explosions in space. This is what I'm showing you right here. They can often outshine an entire galaxy briefly. The Crab Nebula, for example, is the remnant of a supernova that exploded in the year 1054. This was visible in the daytime for a while. It was so bright. Chinese astronomers wrote about it. So the idea is that a supernova goes off in space next to a gas cloud, and the shock front from the collision compresses the cloud, which overcomes gas pressure enough and makes gravity stronger, because remember, gravity is stronger over small distances, that gravity can then take over and new stars can form within this compressed cloud. So that's the first mechanism, compression. The second is cooling. And an analogy I like to use here is if you have a pot of water on the stove, it's just barely beginning to boil, and you throw in a bunch of rice, what happens? It stops boiling because it cools off, right? Where did the heat go? It got absorbed by the rice. So if you have these gas clouds in space and you blow a bunch of dust grains into them, that will cool them off because the dust grains absorb the heat. And when a cloud gets cooler, gas pressure gets weaker, which means it shrinks a bit. And then again, gravity can take over and potentially make stars. So we have compression from supernova explosions, cooling from dust grains being blown into the clouds. And then the third mechanism is collisions. When galaxies collide, we can see the collision front. Often we can see blue stars along that front, and blue stars, by everybody's understanding, are young because they burn very hot. They don't last very long. So there's gas clouds and such in galaxies. So if you crunch together galaxies, then you can crunch together gas clouds and in theory create new stars. And it seems that in at least some examples, we can see evidence of that having happened. But there's a problem with all three of these explanations that I haven't mentioned yet. I've said that supernova explosions can compress gas clouds, but I haven't told you what a supernova explosion is. A supernova is an exploding star. What about the grains and particles necessary to cool the clouds off? Well, those can't be made by the Big Bang. Those can only be made by nuclear fusion inside of stars that then explode. And as for colliding galaxies, in order for galaxies to collide, they first have to exist. And galaxies are made up of billions of stars. So for star formation to happen, what do you need to exist first? Stars. All the mechanisms to overcome these problems require stars to already exist before new stars can be made. So what does that remind you of? Right? You need stars to make stars, just like you need chickens to make eggs and eggs to make chickens. And secular scientists acknowledge this. This author said the process by which an interstellar cloud is concentrated until it's held together gravitationally to become a protostar is not known. Once you have stars, further generations can form. But where did the first generation come from? One of my astrophysics textbook says, literally hundreds of ideas on how stars are formed have been advanced in past decades. However, we are still far from any real solution. This was a comment made recently. We exist. Therefore, we know there must have been a first generation of stars. Well, this requires a little bit of explanation. The Big Bang, even if it had occurred, could only make a limited amount of elements: hydrogen, helium, a little bit of lithium, maybe a tiny amount of beryllium, and that's all. What are we made of? Well, we have hydrogen, but we also have oxygen, calcium, carbon, all these other things that the Big Bang couldn't have made. Where then did all this other stuff come from? Well, supposedly from nuclear fusion inside of stars. So you see the logic here. We exist, therefore stars must have made us, which means stars must have formed somehow. But is that good logic? I've actually had evolutionists make arguments like this. Well, we exist. That's how we know evolution is true. I say, well, okay, we exist. That's how I know creation is true. Are you satisfied with that argument? No, because it's the same logic you just used. Not a valid argument, regardless of who's using it. But this is respected scientists making statements like this. So just because someone has a PhD doesn't mean that they're always going to use valid logic. So that's the problems of star formation. What about galaxy formation? Well, galaxies in our current thinking is, I should say, in the current thinking in the community, is a bottom-up process. You make stars first, and then they gather together into galaxies. Well, if you can't make stars in your model, then you can't make galaxies either, right? Which is why a completely satisfactory theory of galaxy formation remains to be formulated. This author said, the formation of galaxies and larger scale structure remains TMIUPIMA, the most important unsolved problem in modern astrophysics. This author said, it's rather embarrassing that no one has explained their origins, talking about galaxies. Most astronomers and cosmologists freely admit that no satisfactory theory of galaxy formation has been formulated. In other words, a major feature of the universe is without explanation. So who heard this perspective in the last science program you watched, or the last science book you read, or the last science museum you went to? Did they talk about this kind of stuff? No, they say all is well, we have it all figured out. That's not good education. There's other problems with the Big Bang model besides these, which I won't take the time to deal with tonight. Again, that's a whole separate topic. My purpose for right now, though, is that the Big Bang isn't a good model, even before the James Webb was deployed and was launched and deployed. And indeed, that telescope is just making things worse. So earlier I said that the James Webb should look far enough into space to quote unquote be looking back in time, where we should be able to see immature galaxies in the process of forming right after the Big Bang, or several billion years at least after the Big Bang, because as I said, it should take some time. So before discussing that, we need to discuss, well, what is a galaxy anyway? Well, a galaxy is a system of stars, gas, dust, etc., gathered together into the structure. And galaxies come in a bunch of different flavors. Our Milky Way galaxy is a spiral galaxy. This is what it would look like if you were outside of it, which we certainly are not. But if you could go out and look down, it would look something like this. But spirals are not the only kind of galaxy that there are. Astronomers have classification or categorization schemes based on the galaxy's morphology, based on their structure and appearance. And there's a lot of detail here that we don't need to go into. I'll just visit a couple of the major ones. So spiral galaxies, as you see here, there's a central bulge and a disk, which contains spiral arms. There's lenticular galaxies, which have a bulge and a disk, but no arms within them. There are elliptical galaxies that are just basically round or oval, I almost said clumps of stars with little structure. And then there's irregular galaxies that are not symmetric. There's no nucleus. It's basically just a big blob in random shapes, more or less. Now, secular astronomers believe that all this formed over long periods of time. So, of course, they had to come up with some scheme for how one of these could develop into the other. And the basic overview of galaxy evolution, I mean, there's more details than this, but here's the basics, is that the Big Bang happened for a couple billion years or so. There was nothing, the dark period. Then galaxies began to form from stars. The first ones were dwarfs and irregulars. And dwarfs, of course, as you can gather by the name, would be small. And irregulars, just sort of blobs. They would merge and combine into disk galaxies, some of them spirals, some of them just lenticulars. And then over time, long periods of time, the disks would merge and collide and produce the ellipticals. Now, again, there's variations of this, there's more detail, but this is the basic idea. You start with irregulars, then you go to disks, then you wind up with ellipticals. And as I mentioned earlier, the whole process was supposed to take 3 to 6 billion years for the first ones to form. Problem is, that's not what we've been observing. And this has been going on for quite some time, long before James Webb even. So the Hubble Space Telescope was launched in 1990. And once some initial problems that it had were cleared up, we started getting really good pictures from it. So here's an example, a familiar structure to many of us, the Big Dipper here. I don't know if you can see that little tiny rectangle right there. Hard to see on this slide, I don't know. But that little rectangle is expanded to this one in the middle, this one here for you folks over there. And then within that big rectangle, again, that little line over there, this smaller rectangle is blown up here. So that gives you a perspective of, this is a photograph from Hubble, and this is how much space it takes up in the sky. That fraction of that little tiny rectangle there. So Hubble can take very good photographs of very tiny parts of the sky. And there have been some famous versions of this published, like the Hubble Ultra Deep Field, where there's thousands of galaxies in one photo. And the photo, by the way, represents the amount of sky that would be blocked out if you held up a grain of sand at arm's length. If you did that, go outside at night and hold up a grain of sand, how much of the sky is that blocking from your view? Not your fingers, just the sand. I mean, hardly anything. But behind that grain of sand are thousands of galaxies, if you only had the capability of seeing them. So Hubble already had the ability to see some really amazing things. Hubble could look so deep into space that from a Big Bang perspective, we were seeing back in time 13.2 billion years. Now the universe is supposed to be 13.8 billion years. So Hubble was able to see back to 0.6 billion or 600 million years of since the Big Bang had supposedly started all this. And already, even with Hubble, there was something called the early mature galaxies problem. Now, this is in the early 2000s, like 2004, 2005 timeframe, where we were getting all these images back, and scientists were expecting to see early immature galaxies, even within Hubble's view, but seeing mature galaxies even at these vast distances. As this author said, we expected to find basically zero massive galaxies beyond about 9 billion years ago, because theoretical models predict that massive galaxies form last. Instead, we found highly developed galaxies that just shouldn't have been there, but are. This author said, we're detecting galaxies we never expected to find, having a wide range of properties we never expected to see. We are really amazed. These are the earliest, oldest galaxies found to date. Their existence was not predicted by theory. So Hubble was seeing mature galaxies out to the limits of its ability to observe, which secular scientists did not expect, as we've said. But they did have one source of comfort in all this, is that at these farthest limits of Hubble's ability to see, at least most of the galaxies looked irregular. So although we weren't seeing the earliest stages, we were at least seeing some evidence of galactic evolution. We were seeing that these immature ones were out there at those distances. Then the James Webb came along. Now, the James Webb has a 6.5 meter mirror, and it has more than 6 times Hubble's light gathering capacity, which means it can take even better photographs than Hubble can. For example, this is a galaxy cluster called SMACS 0723. So this is Hubble's photograph on the left, and this is James Webb's photograph of that same object on the right. So rather than looking side by side, I'll overlay them. So here's Hubble, here's James Webb. So you see how much better these photographs are, right? James Webb is giving us some great ability to observe. And within these photographs are numerous surprises. Now, let me reiterate, these are photographs of things that Hubble had already looked at, the same regions that Hubble had already photographed. Due to James Webb's superior optics, we can now see a lot of new galaxies that Hubble couldn't see there. And it turns out a lot of those new galaxies are disk galaxies. Not irregulars, not the immature ones, but mature disks. And to make matters worse for secular modelers, many of the galaxies that we already knew about that they thought were irregular turn out to actually be disks now that we can get a better look at them. So a lot of new disk galaxies where Hubble didn't see any, and a lot of the ones that were thought to be irregular turn out to be disks also. So due to James Webb, we now understand that there are a lot more disk galaxies out there than was even understood with Hubble. 10 times more disks in this one particular region for this study here. So in looking at places where Hubble had already photographed, James Webb is overturning some of the secular interpretations of what is there. But the issues don't stop there, because James Webb is designed to look more into the infrared part of the spectrum than Hubble is, which means it can see farther out than Hubble can, because those farther objects are redshifted. And if you don't know what that means, don't worry about it. I don't want to take the time to talk about it. But point is, Webb is designed to be able to look farther out than Hubble could. And it is finding in these new regions previously unobserved galaxies that weren't expected by secular folks. As this author said before, James Webb observed the Abell 2744 cluster. Astronomers predicted it should find effectively 0 galaxies from 13.2 billion years ago, but we found 2. Now, 2 doesn't sound like a lot, but a lot of these discoveries were made immediately as James Webb went online. Astronomers didn't have to hunt for these things. They were being found quite easily, which means there's a lot of others there waiting to be found that are a little more difficult to find. So as some examples, here's some distant galaxies. This one here, if you accept the Big Bang interpretation, which I don't, but we're taking their interpretation for the moment, this would have existed only 450 million years after the Big Bang. Now, let me reiterate, galaxies are supposed to need 3 billion years to form. That's 3,000 million. But here's one only 450 million after the alleged Big Bang. This one here, 350 million. This one here, 380. And another possibly at only 250 million years after the Big Bang. Lots and lots of these studies are coming out now. There's new announcements almost every week, it seems. I mean, this instrument hasn't been online very long, and it takes time to gather data and interpret it. So we're just now starting to see the first fruits of all of this. So there's a lot more where these came from, presumably. Excuse me. As this author said, we've nailed something that is incredibly fascinating. These galaxies would have had to have started coming together maybe just 100 million years after the Big Bang. Nobody expected that the Dark Ages would have ended so early. So again, if you needed 3 billion or 3,000 million years to start making galaxies, but these galaxies are in a place where, according to their viewpoint, it's only 100 million years. I mean, what's 100 from 3,000? That's the percentage of time we're talking about. So this was known as the early mature galaxies problem during the Hubble era. It's now more and more being talked about as the impossible early galaxies problem. And you see papers starting to come out with this as their title. There's Milky Way type galaxies in the early universe where Milky Way is supposed to be a very mature galaxy, therefore it shouldn't be back there. The scientist said, we just discovered the impossible. Astrophysical Journal, very respected journal within astronomy, talks about the impossibly early galaxy problem. So if you're a secular modeler, what are you going to do with all this? We're looking farther and farther out. According to your way of looking at things, we're looking closer and closer to the Big Bang. They're running out of room for anything to form within. So I've been expecting actually since, well, almost 20 years now, since the Hubble results started coming out, I've been expecting them to adjust the time of the Big Bang. They need to push it back in time. Even though they say that the 13.78 billion is a very accurate and precise number, I've been expecting that they're going to have to change it. As indeed, some are now suggesting doing. There's a couple of researchers, I believe they're in the UK, who want to make the universe 26.7 billion years old now. We'll just add another 13 billion and call it good. Now, what does this tell us about how precise and accurate the initial statement was, if this can be suggested so casually? Now, I'm not saying everybody's on board with this yet, but I don't really see what other choice they have. Maybe they won't be this extreme, but I think they're going to have to push the Big Bang back farther in time in their model because they're running out of options at this point. So let's compare the two interpretations of looking at all of this data. The secular scientist says that the origin of stars represents one of the most fundamental unsolved problems of contemporary astrophysics. And there is something badly wrong with our standard picture of the origin of galaxies. But the Bible says, by the word of the Lord were the heavens made, and all the host of them by the breath of his mouth. Let all the earth fear the Lord, let all the inhabitants of the world stand in awe of him. The secular scientist says, nobody really understands how star formation proceeds. It's really remarkable. The Bible says, lift up your eyes on high and see who has created these stars. The one who leads forth their host by number, he calls them all by name. The secular scientist said there are so many uncertainties in this picture that at present we don't really have a theory of star formation. The Bible says, as the heavens are higher than the earth, so are my ways higher than your ways, and my thoughts than your thoughts. The secular scientist says, if stars did not exist, it would be easy to prove that this is what we expect. And this author said, the formation of stars is one of the most fundamental problems in astrophysics. No current model can reproduce all the observations. This author said, the universe we see when we look out to its furthest horizons contains 100 billion galaxies. Each of these galaxies contains another 100 billion stars. That's 10 to the 22 stars all told. So write a 1 with 22 zeros after it. That's how many stars there are. The silent embarrassment of modern astrophysics is that we do not know how even a single one of these stars managed to form. There's no lack of ideas, of course, we just can't substantiate them. The Bible says, great is our Lord and of great power. His understanding is infinite. As Psalm 8 says, when I consider your heavens, the work of your fingers, the moon and the stars, which you have ordained, what is man that you are mindful of him? This is a real object in space, by the way. It's called the Hand of God Nebula. And when we look at all this, what do we see? What do the heavens declare anyway? They don't declare the glory of the Big Bang model. The heavens declare the glory of God. The firmament shows the work of his hands. And I think it's wonderful that we live in an era where technology is getting better and better. We are seeing things never before seen in human history. And the more we see, the more we glorify God through it.